Hello everybody, week 2 part 5. In this part of week 2 presentations we will introduce the topic of data structures, and we will discuss arrays, and also we'll define vectors, and we'll talk about the difference between vectors and arrays. First of all, let's define what data structures are. Data structures are a collection of related data items. An array is one type of data structures, and it is a variable that can store multiple values of the same type. These values can be stored in an adjacent memory locations. To declare an array, you use the brackets operator. For example, int test open brackets 5 close brackets. This is an array called test that can hold up to 5 elements. In the definition int test 5, int is the data type of the array elements, tests is the name of the array, 5 in between the brackets is the size declarator. It shows the number of elements of an array. So in this case, you have an array called tests of type integer that can hold up 5 elements. So the size of an array is the number of elements times the size of each element. Array memory layout. The memory layout of the array tests is shown on slide 4. As you can see, each element has its own location in memory. The size of an array is the total number of bytes allocated for it, which is the number of elements times the number of bytes for each element. For example, int test5 is an array of 20 bytes, assuming 4 bytes for an integer. Another example, long double measures 10, is an array of 80 bytes, assuming 80 bytes for a long double. Named constants are commonly used as size declarator, like const int size equal 5, int test size. This eases program maintenance when the size of the array needs to be changed. So you can just change the size variable without having to change the array by using named const. Accessing array elements. How do we access the elements inside the array? Each element in an array is assigned a unique subscript, and subscripts start at 0. The last element's subscript is n-1, where n is the number of elements in the array. So in the previous examples where we have int test5, that means the number of elements in the array is 5, and it starts at 0. So you have 0, 1, 2, 3, 4, where n is n-1. So array elements can be used as regular variables. So if we take an example, tests 0 equals 79, and we have an output of test 0, then an input of test 1. Test 4 is equal to test 0 plus test 1. Arrays must be accessed via individual elements. So if you try to put the output cout tests, that won't work, and it's not legal. So you have to say cout test 4 or cout test 0 or test 1. Program example. In this program example about array, we have a program that asks the user to to enter the number of hours worked by 6 employees, and then it stores the values in arrays. So you have arrays called hours of type integer, and the size of this array is 6. This is the number of employees. Here are the contents of the hour arrays with the values entered by the user in the example output. So for hour 0 we have 20, hours location 1 12, 40, 30, hours 4 30 again, and hours 5 is 15. So the users enter 20, 12, 40, 30, 30, 15 and click and press enter. Then these values get stored in the locations as you see displayed on the screen. Accessing an array contents. The general format for accessing an array is array name then index. For example, in test 4 you have an array 4 equal 10, 20, 30, 40. When a program wants to access the 30, this can be written as tests 3. The next data structures that we want to discuss briefly is vectors. Vectors are one type of dynamically allocated container from the standard template library, or STL. Vectors are capable of storing multiple elements of any defined data type, and they do that in a contiguous block of memory. By default, the elements of an integer vector objects are set to 0. Vector can be defined to store any data type using a declaration of the form vector, then the type, then the name, then the size. Benefits of vectors: they are good when we have an unknown sequence of similar items to store. We want to access them by their sequence number. They are held in a special library and can be used in a file that has include vector. Key facts about vector. This is a list of key facts about vectors that we should keep in mind. For example, a vector is an object that contains a sequence of other objects inside of it. The objects inside must all take up the same amount of storage. They are numbered starting with 0. Another thing is, if the whole vector is called V, then the items in it are written like V0, V1, V2, and so on. The last item is V dot size minus 1, not V dot size, because it starts at 0. New items can be pushed onto the end of the vector. Another key fact is that the last item can be popped off a vector, like we mentioned, and vectors can therefore change size. Furthermore, we can find out the current size of a vector by calling the size property of vector, like v.size. And vectors can be empty. If so, v.empty is true. If a vector is empty, then vi index I and vpop will crash because the vector doesn't have any values in it. Vectors are empty by default when created, so when you first create the vector, it will be empty. And they always should be passed by reference whenever possible. It's not recommended to pass vectors by value. The difference between vectors and arrays are that arrays are like vectors, except that they have a fixed size specified in the declaration. They are faster than vectors, so arrays are better with performance. You cannot add or delete items from an array, and the syntax is simpler. The absolutely no safety belt. If an index has wrong value, you crash. So your system will blow up and your program will crash. This concludes week 2 presentations.